So, a couple of things about the trapezoids. If the graph is concave up, it'll give us an upper sum, meaning it'll be a little bit too big. And if the graph is concave down, it will give us a lower sum, meaning it'll be a little bit too small. And in terms of figuring out the error from approximating the sum using the trapezoidal rule, the error, it just follows this formula, so it's less than or equal to, remember b minus a, is the length of my interval cubed, over 12n squared. Remember n is the number of, will be the number of trapezoids. And then times that by the maximum of whatever the second derivative is. And that'll give us the error. There'll be a couple questions about that on your homework. And it's just a plug and chug. It's just a number crunching. And then in terms of the trapezoidal sum, we talked about, was the midpoint sum equal to the average of the left and right? And the answer is no. In fact, the trapezoid sum is the average. And you could probably come up with a reason, mathematical reason why that should be. What would happen if I took those left sums and right sums and added them together? I bet you could figure that out mathematically yourself. And then the last piece, the last note, is not to confuse the trapezoid and the midpoint, because of course if you show work for one when you're supposed to show work for the other, you will get it marked wrong. But they're the same. They are in fact the same if the function was a straight line. That's the only time it would actually, that would be a special case that they were equal. Okay, turn the page, let's do some problems.